All right, welcome everybody to Voronoi Day 2, and today we're going to talk about a Lloyd relaxation, which is a way of kind of like fixing your Voronoi diagrams. If you remember last time, we had one Starbucks in all of Hawaii over here, one Starbucks in Cabo, one in TJ, and what we did was we asked what regions are closer to San Diego than any other region, what regions are closer to TJ than any other region, what regions are closer to Oaxaca. And this is used for businesses for things like planning. Like you can do a Voronoi diagram of like Save Marts in Fresno, let's say, and see, oh look, this one Save Mart is serving a huge geographic area. So maybe we can put a second Save Mart down here and like split it in two and have better coverage. So like, you know, if you're working for 7-Eleven and things like that, they're always looking like, where can we put another 7-Eleven? Where can we put another Starbucks? You know, and so they use these things to kind of see geographically with the service areas, kind of a particular store. Bruce Wayne, Bruce Lee. Yeah, I think that it's picking up the thing. Okay, so what's going to happen though if we put like what's east of Oahu, like Molokai? Megan, do you know? I think Molokai is like over here, right? Molokai, the leper colony over there, and then southeast of Molokai is Maui over here, and down here we got like the Big Island, right? And so if we have this and we do like a Voronoi diagram, you can end up with something where like you've got this way, split, goes this way. You can end up with like these. This one's gonna go midpoint there. Yeah, so you can end up with these things where you have these like really narrow, like needle-like zones, and so oftentimes we want to do what's called a relaxation on the Voronoi diagram, and what that does, it's all these places are cities, and then Hawaii. Well, this one's Oahu, right? So this is the region of Hawaii, and then we got Oahu, Molokai, Maui, and Hawaii, which is the name of the Big Island, right? It's just Hawaii. So, I don't know. The big one, the Big Island here. Oops. The Big Island. There we go. Okay. And so what the relaxation does is, it sounds complicated, but all you do is you move the center point of every one of these Voronoi regions. This is going to come up here maybe. You move it to the center point. And so you're going to move Molokai, so to speak. You're not going to do this if you're doing like a geographical information system, but you do this if you're like generating fantasy kingdoms and things like that. Oftentimes we just pick random points on the map and then we Voronoi it, and it works pretty well, except sometimes we get these really needle-like lands that just don't look very good or realistic. And so what you do in a relaxation is you will move the island of Molokai from its historical home over here as a leper colony, and you move it up to the centroid, the center of mass for this region. So you see how we've got this country here? This is the country of Molokai. All this is colored in Molokai's colors. And we are going to move the seed, the center point of Molokai, to the center of mass of that region. And then we do the same thing for San Diego, which might be like over here somewhere. And TJ might move, I don't know, here it looks right in the center. And Cabo might move down here. And Oaxaca might move, I don't know, over here somewhere. I don't know. And you move the seeds. And then you rerun the Voronoi algorithm. And that's, what if we took Bikini Bottom and then move it? Yeah. 2 weeks ago being quiet. Nice. And so, obviously you can't move islands in real life, but if you're doing like fantasy kingdom generation, if you're making skin cell textures, if you're making cobblestones, what you can do if you're making a cobblestone is you do the Voronoi, right? And then you just draw the cobblestone kind of like this, right? Like you just have, you know, different cobblestones and they'll all fit together in different ways. And so you can use this to procedurally generate cobblestones. You just scatter seeds on the ground and do a Voronoi, and then you do a little thing where you like round the corners off and things like that. Do a little bump mapping action here, so the light's reflecting, off the edges of the cobblestones as if they're rounded, and you got like a very easy generated cobblestone effect for very little effort. So how do you take the centroid? Okay, so the centroid means center of mass. If you guys have ever done martial arts, that people will always talk about, use your center of mass, find your center, I think Mulan, I'll make a man out of you. They say, if you find your center, something, something, something. The center of mass is very important in martial arts. It's also important in engineering. If you have some weird shape, a lot of times the center of mass, whatever it is, you can treat that entire object as if it's just the center of mass. So if you had like a string or something like that, you can just suspend it from that point, and then the whole thing will be perfectly balanced if you have it right on the centroid. Okay. This doesn't work if you're like rotating it and things like that. Then you've got like a rotational, inertia and things like that. Figure out how to do the relaxation, or figure out how to do Voronoi, because Voronoi is like to do this on a grid-based system. The Voronoi, on a grid-based system. Let's just go over how to do Voronoi then real fast. You got a grid. You got Y number of rows, right? You've X columns. Right. In this case, we have 5 columns. We got 4 rows, and we've got a city A and a city B and a city C. Okay. And so what you do is you say for each row, for each column, here, take the distance to the 3 cities. So the distance to A is 1. The distance to B is let's do Manhattan distance just to make it easy. 1, 2, 3, 4, 5, 6. And the distance to C is 5. Okay. And so A is 1, B is 5, and C is 1, 2, 3, 4, 5, 2, 3, 4, 5, 5, 5, 5. So this guy is closest to A. So you just do the Pythagorean theorem instead of Manhattan distance. And so you can just color this square in as red. You do the same for this one. This one's closest to A as well. You do the same for this one. This one's 1, 2, 3 away. This one's 1, 2, 3 away. So you can do a tiebreaker, somehow flip a coin. I'll just call it A. I don't care. Then this one's closest to C. C will color as green. This one is 1, 2, 3, 4, 5 away from A. It's 1 away from C. It's 1, 2, 3, 4, 5 away from B. So that is closest to C. So C color is green, I guess. The A color is red. Right? This is going to be A. This one's a tiebreaker, which I guess I'll give it to A. A, 1, 2, 1, 2. And then we'll make B blue. And then we'll do a tiebreaker. I guess we'll do it alphabetically on tiebreakers. So this one is 2 away from A, 2 away from B, and 2 away from C. So I guess, like I said, I'll just do this as a tiebreaker alphabetically. So I'll do the A region. This is 1 away from C, 2 away from B, 3 away from A. So that is going to be green. Like I said, just for every row, for every column, you just do high pot, high pot, high pot, high pot, high pot, high pot. And that's it. 2 away, 1 away. So this is going to be green also. And then this one, I'm not really doing it in the right order. I should be scanning across like this. And then this one's also going to be B. Okay. And so that is a Voronoi. Okay. You want to do it the right way? Nah. Because you have to output everything to the screen one cell at a time. So there's absolutely no reason to, do any more work than you need to for this. Because you're going to have to output on every cell anyway. So if you're doing a tile-based system, you might as well use a tile-based, Voronoi. Although, it's not. Everyone says high pot, but nobody says how pot. Okay. You do not remember the center mass. It's been so long. It's called the dungeon in Taekwondo. So that's your COG, your dungeon, if I'm probably massacring it. Kearney's like, just do it wrong. Yeah, it's simpler, dude. Like, this is not supposed to be a killer assignment. It's a doubly nested for loop for every row, for every column. Hypot to all the cities, and output the color for the closest one. That's it. How pot, why pot. Yeah. So once you got this, now you're going to need to do the centroid. Okay. So how can we find the center of mass? And I think C is already in the center of mass, and B is already in the center of mass, depending on how you round it up or round it down. A, though, I think might need to move right one to be in the center of mass. Maybe. So how do you compute the center of mass for the A region? Okay, and yeah, you average all the rows and columns together, right? And so to compute the center of mass for A, what you're going to do is just you're going to add all the rows together. So 0 plus 0 plus 0, 1 plus 1 plus 1, 2 plus 2, and a 3 is 10. 10 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9 equals 1.1. So we're going to be on row 1. And then we'll do the same for the columns. 0, 0, 0, 0, 1, 1, 1, 2, 2. So 1, 1, 1 is 3, and 7 divided by 9 is equal to 0 and 7, 8, something like that. So yeah, it'll actually stay on row 0. So that's already at the centroid, basically. Maybe it's closer to column 1 than it is. Maybe if we round it, then the centroid will move. So A will move to here, and now we rerun the algorithm. Okay, so this is how the relaxation works. You add up all the rows, and the new row that it's the center point, the seed point is going to be at, is the average of all of the row values, and the new column that it's going to be at is the average of all the column values in the territory. And that's it. And you just move the capital there. C and B are already at their centroids. I can tell that from just eyeballing it. And so we then rerun the Voronoi. And let's see here. 1, 1, 1, 1. I think it actually, the only change is going to be here, because we're tie breaking based on alphabet. I think that's the only change. 1 away, 2 away. Okay. But what it looks like on the server is this. Let's see, what the heck is that? CD Voronoi 2. If I could spell Voronoi properly. Run it. So there's the Voronoi, and then we do a relaxation. You'll notice that I is going to move like left, P is going to move to the right, because these guys, they're right on the edge of their own territory. So what happens, they're going to move, the P is going to move right, the I is going to move left, right here. These guys are going to go like this and move towards the center of their territory. M and N are going to maybe shift a little bit. C here is a huge province. And this is what I'm talking about. Like if you did a Voronoi of like Save Mart, and one Save Mart was covering all of this territory, you'd be like, all right, we need to put a new Save Mart in, like in the bottom right. So C is going to move like probably, I don't know, 4 or 5 tiles southeast. So, okay, so keep an eye on I and P, and keep an eye on C here, and watch how they move. So you go, C, oh, I scrolled. Oh. Okay, anyway. So C moved down that way, I and P went away from each other, and at the end of the day, we had some of these provinces that were like kind of long and oblong, and it kind of rounds them a little bit. So doing one iteration of relaxation usually fixes the worst problems, and you end up with reasonably scattered, capital cities, seeds, whatever. If you do 2, that's usually good enough. If you keep doing it though, then all of them will just move until they're all sort of equidistant from each other, and it forms a very boring pattern. It's always going to look like something like this. So, you can do that if that's what you want. Usually, though, when you're randomly generating things, just one relaxation is enough, maybe 2. So, what do we have on chat here? Talking about CSUMB. Okay. Yeah. Okay. So that'll be. I'll give this one to you guys after you finish Voronoi Part 1, which is due on Tuesday. So what I want to work on with you guys actually is math. Okay, because you've been demanding it, you've been asking for it. So let me stop this recording because it's kind of on a different topic, and I will start a new recording on math. I know the people have been demanding it. I know. Barycentric coordinates. Here we go.